Well, Google, Facebook, Instagram, or any other websites we use in our day-to-day life comes under the normal web or surface web. Surface web is easily accessible and we all use it in our day-to-day life. But the twist is the surface web is only 4% of the internet. Yes, you hear it right. The surface web is only 4% of the internet, and we all know how big the internet is. The question is what inside the remaining part of the internet? The remaining 96% of the internet. Hello, curious mind. My name is Krishna Singh, and I'm working as an intern at Vivid India. I'm here to take you on a ride to explore the hidden part of the internet. The internet has changed everything from the way we work, from the way we play, to the way we live in. It seems like there is a corner of the internet for everyone. Despite what interest you have, what your beliefs are, there is some things we think the same way. There is someone who thinks the same way you do. The internet has connected in a way that were never before imagined. It's a place where everyone from anywhere on the earth can come together. There is so much stuff on the internet. Most of us don't know it exists. If you want something, anything, whether it is a product or service, legal or illegal, the internet has it. You can choose it for good or bad. Much like the surface web we use every single day, the dark web is full of websites and forums and services that we can use, but it is hidden under the layer of protection. The dark web is a heaven of illegal activities and it goes deep, much deeper than you have imagined. It's a place where criminal, predator, spies, drug, and even human traffickers lies. And it's all hidden in a plain sight. You can access it in a minute if you wanted, but should you? Well, you can break down the internet into three categories. We have the surface web. This is everything that you see on daily basis. YouTube, Twitter, any social media at all. It's relatively easy to find anything on the surface web as everything is indexed by search engine like Google. Every second, over thousands of posts, photos are posted on Instagram. 8,000 tweets are done on X. 70,000 Google searches take place. From these, the surface web seems to be very massive. Almost everything you do can found here. You can look up anyone and find some kind of information about them and their life. But you can't find things like their bank account or medical records. These things are hidden under password protected websites where only they can access them. This is where we enter into the deep web. The deep web refer to the content on the internet that is not indexed by search engines. Basically, if you can't find it on Google, technically it is on the deep web. If you have ever logged into your email, you have browsed the deep web technically. And I know it might be a little disappointing that the deep web is not as cool as sounds. It's pretty much just as mundane as the surface web, but with just a bit secrecy. But realize that the deep web is the most massive part of the internet. The deep web contains 96% of everything which is on the internet. You don't put a dent on the amount of information available there is on the internet. It's just too much to go through, most of which you couldn't even get when access to. But even further, even deeper than the deep web, in the tiniest slavery of the internet, lies the part of the web where websites are encrypted, sliced without IP addresses to make them nearly unrecognizable, accessed by user with encrypted software to completely mask their identity. And here, everything and anything goes reach to the dark web. But how does it even work? How can you hide from the rest of the world on something that pretty much everyone has access to? If you if you're browsing the surface web, chances are FBI is watching you. Well, not really, but for average person, whatever you do online can be, and in many ways, will be tracked. Many websites will track what you're searching and looking at it, will advertise products and services to you that fits your descriptions. This isn't anything new. Facebook, Amazon, and most of the social media sites are guilty for this. They sell your data to the advertiser around the globe, and you agree to it in those terms and conditions. You didn't read it, and this doesn't happen by incident. The internet wasn't meant to be anonymous. Some people see it as an invasion of privacy, and others don't see it as a problem at all. But how far we let it go before it turns bad? Well, let's understand what happens when you browse something. Let's see Alice and Bob. Alice want to send some information to the Bob server. Alice want it to be private. Now, in order to send a message to the Bob or Bob to send a message back to Alice, the fundamental nature of IP address require all the router that are in the path. So you can see Alice and is want to send a message to the Bob server in the slide, and the path it take as A, B, C, D. So the IP protocol require all the router that are in the path are going to see IP packets, either destined, either Bob from Alice or Alice from Bob. All these routers see the IP packets and see the source and destination address. So if someone is trying to determine who is Alice talking to when see accessing content of the server run by the Bob, all they need to go, all they need to do is to get the access of any of this router. So we have 4 router over here in the path, and all they need to get access of any of these router. And these routers or networks are run by the big organizations. It's not infeasible that that, for example, the US government or the Chinese government or the North Korean government have access to any of these router. Will able to spy on the traffic that running across it, and every packet that exchanges between this router carries the source and destination fields that are required by the IP protocol. So it's very easy for someone to identify that Alice and Bob are communicating with each other. Okay, let's talk about how we solve this problem. The solution involved in something called onion routing. Onion routing requires some security and some encryptions. But I just want sort of I want sort of illustration, the main principle. I will just show you the sort of illustration, the main principle without getting into the core details. The main thing in onion routing is to establish a connection between Alice and Bob. So if Alice want to send the information to the Bob, onion routing will first make a connection between Alice and Bob. It will suddenly find a path. When the router and the path don't know where the packet is destined to go and where it come from. Now, when Alice send a message to Bob, the Tor client will scan all the nodes in the network. So on the diagram, you see, pardon for the diagram, but in the diagram, you see the nodes are there. So there's a network and there are nodes, certain nodes. The Tor client will scan all these nodes and will decide a path, find a route to reach to the Bob server, in which broadly 3 types of nodes are there, mainly entry node and middle node and exit node. After the client finds a route, it will lock the message sent to Alice to Bob in a different layer as per the nodes. And each node will have a key to unlock its respective layer, which means every node will have one key per layer. So when the message is sent to the first node, it will unlock the first layer, and the node will only knows which node it should forward the message. Similarly, for the middle node, after unlocking the middle layer, it only knows which next node to forward this message. And this process is repeated until it reaches to the destination server, and the information is received at the server and safely. For the layer security, it is called as onion routing. The onion routing. Well, over 24 years ago, the US government wanted a system to protect their communication online. Since the internet wasn't designed for everyone and everything should remain anonymous, in a way, anyone could intercept the government transmission while they are being relayed. And this was unacceptable. So in the mid 1990s, researchers began working on onion routing. Onion routing protect any data sent by wrapping it with multiple layers of encryptions, where the innermost layer contains the message. So in the slide, you see we have a message hello, and it is sent safely to the Bob server. Because of onion routing, darknet like Tor can exist. Tor stands for the onion routing, a software named after a technology that made it possible. It seems just like any other normal web browser, but through Tor, you can access dark web. You can access web pages that aren't available on the surface web. or to the general public. The dark web also serves as a more illicit purpose. For example, journalists, human rights activists, and law enforcement officials may also all use the dark web to anonymize their online activity. Additionally, organizations like Facebook's BBC News and New York Times have launched parallel versions of their sites that are designed specifically for the dark web, making them accessible in countries in which they are actively blocked or censored. While Tor provides access to the dark web, it also comes with significant risk. Many areas of the dark web are filled with illegal activities, including drug trafficking, weapon sales, stolen data exchange, and other criminal activities. This anonymity can be double-edged sword. It offers protection for those seeking privacy and security, but also shields those with malicious intent. The dark web is neither good nor bad. It is simply an anonymized virtual space where users of the internet can operate with greater anonymity. As a final comment, the dark web is not a place for casual browsing. Most of the material that typical user wants to access exists on the index World Wide Web, which is surface web. The dark web, by contrast, allow users to access specific sites and services which are typically not meant to be accessed by general audience. Thank you. Surf internet safely and privately.